Hi everyone, this is Joe from Healing Math Trauma. I'm going to talk today about how to multiply decimals and why decimal multiplication works the way it does. Why it's not kind of some arbitrary rule about counting how many places over to put the decimal point, but why it actually does make a lot of sense. In this video, I'm going to be using fraction multiplication to help us make sense of decimal multiplication. So if you're a little shaky in fraction multiplication, make sure you watch my last middle school video from last week where I explained how to multiply fractions. All right, let's get into it. Understanding decimal multiplication.
One way that we can make sense of decimal multiplication is to actually turn it into multiplication of fractions. And if you're thinking to yourself, wait, how am I supposed to turn these decimals into fractions? It's actually more straightforward than you think. What we have to do is think about the place values of these different digits. So when I have 0.05, this is the ones place, this is the tenths place, and this is the hundredths place. So when I convert that into a fraction, this is literally 5 hundredths. So 5 over 100, 5 hundredths. Now when I look at 1.2, this is the ones place and this is the tenths place. And so 1.2 is 1 whole and 2 tenths. Well, 1 whole is the same as 10 tenths, and so altogether, this is 12 tenths. So 0.05 times 1.2 is the same thing as 5 hundredths times 12 tenths. And I can see that just by looking at the place values of these different numbers. In my last middle school video, I talked about fraction multiplication and why it is that when we're multiplying two fractions like 5 hundredths times 12 tenths, we just multiply the numerators and multiply the denominators. So if you don't quite remember why that's the case, go ahead and check out my last video from middle school, how to multiply fractions. But now that if I remember that, now that I've converted these two decimals into their fraction equivalents, well, now I just need to multiply 5 times 12 and 100 times 10. Well, 5 times 12 is 60, and 100 times 10 is 1,000. So I have 60 thousandths as my answer. And if I want to convert back into decimal form, maybe because that's how the problem was originally given to me, again, I just need to think about place value. If I want 60 thousandths written in decimals, I need to think about, well, what place value would that be in? So here's the ones place, the tens place, hundredths place, and thousandths place. And so if I want 60 thousandths, I need to have the number 60 for the thousandths. So that's 6 for the hundredths and 0 for the thousandths, so that 60 is sitting in the thousandths place. So 60 thousandths is 0.060. And so that is how we can figure out how to multiply decimals by first building off of what we know about fractions, taking our original numbers, using place value to convert them into fractions, doing the fraction multiplication, and then again using place value to convert this back into a decimal. And that's one way that we can think about multiplying decimals. Now, another way that we can think about this is to just really do some estimation and think about what makes sense. If I know that at the end of the day, multiplying these two things is going to be the same thing as multiplying 5 times 12 and then figuring out where to put the decimal point for the answer, I can think about what makes sense. Well, 1.2 is a little bit bigger than 1. When I multiply 1 times a number, that I don't change the number, right? And so if I'm multiplying by something that's a little bit bigger than 1, my final answer should be a little bit bigger than 0.05. If I did 0.05 times 1, I would just get 0.05. But since this is a little bit bigger than 1, I should get something that's a little bit bigger than 0.05. Well, what are the choices about where to put the decimal point here? Obviously, 60 is too big. If I put it right there, and have it be 6.0, that's still way too big. 0.6 is way bigger than 0.05, and so it's not a little bit bigger, it's quite bigger. If I move it 1 over or 2 over, I can see that this right here is the only choice that makes logical sense. 0.06 is a little bit bigger than 0.05. This is way bigger and this is way smaller. And so I can also just use estimation to multiply two numbers and then say, okay, what is the only logical choice for where I put the decimal point? And while this might not seem as precise a strategy as, like counting over how many spaces you're moving the decimal point, it actually relies on number sense. And anytime we're asking kids to estimate and to think about whether or not their answer is reasonable, that's a good thing. Because so often kids will forget things about rules for decimals. They'll miscount how many decimals they move. How many spaces they move the decimal point over, and then they'll make all these random mistakes. But if we train kids to think about what's a good, reasonable estimate for this answer, and then to think about, okay, maybe I did this here. Oh, that looks like a good, reasonable estimate. That's always a good thing. Now, I'm not saying that kids should be converting to fractions every single time they need to multiply decimals, but this right here helps explain why we're getting the answer that we get. And it's always a good idea to think about the reasonableness of our answer and estimating what we think would be appropriate.
Thank you so much for watching. As always, if you have any questions or you're wondering how to help your kid with this type of stuff, please hit me up in the comments. I'd love to answer any questions you may have.